The last part of the notes that I'll do with you are the parts of given the graphical representation, how might we produce the algebraic representation, or the equation is another way of saying that. I know that this is a square root function in the first example here. It seems just by looking at it that there's a reflection someplace, there's a shift left, there's a vertical stretch, it seems. So if I'm setting up the equation, then I know that there's going to be some leading coefficient. There will be some shifts, x plus h. I guess I should write that as minus h, just to stay consistent. And plus k, and it's just a matter of determining each of these appropriate parameters. Well, the hk stuff comes from the coordinates of the endpoint. Sound really nasally. Um, if the endpoint is negative 2, 8, then the first step that I can start is by substituting in negative 2 for h, meaning that this becomes a plus 2, and 8 for k. And that should remind me that I have an appropriate shift left 2 and up 8 from the end point of the parent function. And that seems to be the case. From here, the approach that we've utilized before was to pick another point on the graph and substitute it in for x and y to solve for a. And that is one approach that you're welcome to use, or another approach that's easy to see with radical functions is from the endpoint, determine uh, how many units you're shifting up or down and left or right from the end point. So in this case, um, it happens to be the case that from the end point, in order to get to the next whole number point on the graph, I have to go down 1, 2, 3 units to go right 1 unit. Down 3 to go right 1 unit. Just as a quick heads up, that tells us what the a value is for a radical function. That just happens to be what it is. That a is negative 3, meaning our function is negative 3 square root of x plus 2 plus 8. If you're not comfortable using that approach, then you can use the approach that we've done before of picking another point on the graph, substituting it in, and solving for a. And it'll show you that you end up getting negative 3 as well. So let's go with that approach. I know another point on the graph is, I don't know, instead of using negative 1, 5, I'll use 7, 1 in this case, or 7, negative 1. That means that negative 1, or y is negative 1. We're solving for a. X would be 7. 7 plus 2 is 9 plus 8. If I simplify, that's a negative 1 is equal to 3a plus 8. Subtract 8 from both sides, negative 9 is equal to 3a, or a is negative 3. Oh, a confirmation of exactly what I said. The cube root function works the same exact way, that start with the parent function, y equals a times the cube root of x minus h plus k, and determine the a value by looking at how the other points on the graph of the function are transformed. While it would be easy for us to find the a value if we could use this approach, we don't with certainty know exactly whether or not this point passes through 3, 3. So we're going to use only the approach that we are certain that we can use, pick another point on the graph, and substitute it in to solve for a. But starting, we first determine the transformations of the point of inflection. The point of inflection is at 2, 1, so that means I've shifted the point of inflection on the parent function from 0, 0 to 2, 1, or a shift right 2 and up 1. So y is equal to a times the cube root of x minus 2 plus 1. And now pick another point on the graph. I'll be interesting. I'll pick negative 6, negative 3. Negative 3 is equal to a times the cube root of negative 6 minus 2 is negative 8 plus 1. Or simplifying, that's a negative 3 is equal to negative 2a plus 1. Subtract 1 from both sides. Negative 4 is equal to negative 2a, or a is equal to 2. So the graph of our function is y equals 2 times the cube root of x minus 2 plus 1. That's all I have for you today.